In this video, we're going to take a closer look at the Schematix dual drive extruder. We're going to be going through its features and also how to build it. So due to this video being a lengthy one, encompassing the topics around this extruder, I'm going to leave a host of links so you can skip forward in the video to any segments you would like to watch. First thing we're going to talk about is features. As the name would suggest, this is a dual drive extruder, and you may or may not be new to this term. They've been around for a while, although we're starting to see them more popular on the market. Basically, a dual drive extruder is an extruder where rather than having a drive gear on one side and an idler, normally a bearing on the other, pushing the filament into the drive gear, with a dual drive extruder we have two drive gears, both mechanically driven from the stepper motor, pushing the filament in between the two and forcing it down into the extruder. The advantages are fairly obvious. You get far more traction on the filament, and quite often these setups are ideal for flexible filament, which can sometimes be tricky for extruders to properly extrude without slipping. Another cool feature on this extruder is it has a very easy to use idler release. Simply pull back on the tab on the top of the idler to insert new filament or pull out your old filament. Now for this extruder, we have a 3.5 to 1 gear reduction, nothing too unusual about that. However, it does mean we can use a pancake stepper motor. This is a very small stepper motor compared to most conventional stepper motors you'd see on a rep wrap or similar. The advantages are fairly obvious: huge weight saving, less weight on any axis usually results in better quality prints. You get less shaking from a quick jerk, stop-start movement. The axis is a bit more rigid, and that translates into a better quality print. Now, you don't have to use a pancake stepper motor. However, I do recommend it in the sense that it's not a very expensive upgrade, and it's a great feature to use along with this dual drive extruder. This extruder does support PTFE liners in two ways. The first is you can screw in a piece of PTFE liner onto the top of the extruder. You can have this two ways. You can have a short piece of PTFE liner like I've got here. Now this helps guide the filament into the top of the extruder before it enters. Or you can have a longer loop of PTFE liner going to some other mount you've got on your 3D printer. That setup I'll be probably adding to mine at a later date. The second way that supports a PTFE liner is from the extruder gear all the way down into the E3D Hotend. This helps guide the filament and make sure it doesn't get too hot before it enters the hot zone on your Hotend. Alright, so I'm not going to go into a detailed list of all the hardware I've got here because there'll be a full list in the video's description if you want to check out all the nuts, bolts, washers and miscellaneous used for this build. This is the main body of the extruder. I've printed mine in PETG. Kind of looks like it's almost got glitter in the filament, but that's just because it's I've got several rows of LEDs above the camera here, so it gives it that effect. Wish it looked like that in real life almost. This is the idler arm, and we've also got the locking block for the E3D V6, and this should also work with the V5 Hotend, so they both have the same mounting hardware. Here we've got some stainless steel extruder gears. These are purchased off eBay. I think they're only a couple dollars each, pretty cheap. We're going to need two of them. Here is the drive gears and cogs for the extruder. Now I've printed mine out of Tillman alloy nylon filament. I don't recommend you rush out and buy a roll just for printing these gears because they'll be pretty expensive gears by the time you finish buying the roll. But if you do have some nylon filament around, it's always a good idea to use nylon filament for gears. However, if you print this out of your favourite flavour of filament, excluding PLA, because obviously it's not going to be temperature resistant for an extruder, it should be just fine. Here's a eBay purchase again. This is sometimes referred to as a pancake stepper motor. It is a Nema 17 form factor, and for reference, here's a fairly typical Nema 17. And you can just see the size difference there. So this is going to be a huge weight saving feature. I've got some 2-part epoxy over here. We're going to inset a screw into the extruder body, a nut rather. As far as tools go, pretty basic. You're going to want a drill and a 4 and 5mm drill bit, a couple of Allen wrenches, and a ring spanner would be pretty handy too, 8mm for doing up the nuts. So let's get into construction. So I've taken one of the M4 nuts, the standard, not the Nyloc, and if I can get the camera to focus, I've just roughed the edges with a file just to give the epoxy something to grip into. So I'm just going to apply a small amount, and I'm going to get this all over my fingers brilliantly. And this nut gets installed just there. So one thing we want to make sure is when our drive gear is installed on our drive bolts, that the grub screw here doesn't protrude above the drive gear, and in this case you can see it protrudes about 1mm above. So we're going to have to shave a bit of metal off this grub screw. So I'm going to remove the grub screw with an Allen wrench, and I'm going to clamp the Allen wrench with the grub screw on the end into a vise. Then I'm going to take my file, making sure I push down firmly. I'm going to proceed to remove enough metal until the grub screw no longer protrudes above the top of the drive gear. And install it back into the drive gear. Slip the drive bolt on, if I can get the camera to focus. There we go. Now you can see it's just below the edge of the drive gear, and that's exactly what we want on both drive gears. Now you're going to want to drill out some holes here, clean them out, make sure they don't have any plastic that's been over extruded or anything. Now with the 4mm drill bit, you're going to want to drill out this hole, this hole. These other ones should be fine because they're oversized, but make sure no plastic has been extruded in this hole and this hole. And finally these 2 holes down here as well. When it comes to the locking block, same deal, you're going to want to clean out both these holes, make sure they fit in the M4 bolt, and also this hole right here. With the M5, basically all that's used for is if the bolt doesn't fit too well through the extruder gear, then we can just drill that out to M5 size, or 5mm. Same goes for the Nema drive gear. These 2 gears right here, you can see they've got a keyway, sort of a half moon shape, so we just leave those as is. You'll see how that comes into play later. Next we can press in our bearings to the idler arm and also the main body of the extruder. These are a pretty snug fit. You might have to chamfer the edge of where the bearing is seated to get the bearing started, because sometimes it wants to go in wonky. Now there is 3 standard M4 nuts that go on the back side of the extruder. Now sometimes these don't print perfectly square, or there's a bit of overhang and the nut doesn't want to go in. So I'll show you a quick trick. I'm going to thread the nut on to an M4 bolt, and I'm going to use a jet lighter, and I'm going to heat it up for 5 seconds. Five seconds-ish. And then I'm going to make sure it's aligned and then press it in to the hole, and that's just cleared the way for any over extruded plastic. And they also get a fairly good bite in the plastic. They don't want to just fall out, they're pretty in there. So I'm going to continue to do that for the next two nuts on the back side of the extruder. So I've got our M5 hex bolts here. This is the 70mm and 60mm version, and we've got to mark these. The M5 by 60 has to be marked at, measuring from the end of the bolt, 25mm, and the M5 by 70 has to be measured from the 20mm in from the end of the bolt. To make this easy to spot, because we've got to flat grind a couple keyways on these bolts, I'm just going to use a bit of masking tape to mark the measured points so it's easy to spot when I'm grinding. Alright, so I'm at the grinder with our two M5 drive bolts. You could do this if you don't have a bench grinder. You could do this with an angle grinder if you're careful, or even with a file. Now we have to, sorry about the squawking in the background, I've got a pet, and I say pet loosely because he's wild, fantail, which is a native bird in New Zealand, and he just thinks I'm the bee's knees basically. Anyway, we've got to grind a flat spot into our M5 drive bolts to match the half moon keyway on these gears here. Now, measuring from the flat spot across, it's 4mm. So we have to take a millimetre off our drive bolts, and I'm going to measure that using a pair of vernier calipers. So here's one of the bolts I just finished grinding. It's a flat spot and it's a snug fit. You don't want it too loose. You can see it slides on there, there's no slop. And that's our drive gears finished, and put those aside and work on the next thing. So next we need to shorten our countersunk M4 by 40mm. We're going to measure from the head of the bolt. We need to cut it right at the 34mm mark with a hacksaw, and then I'm just going to deburr the edge with a file so the nut still threads on easily. Now next we're going to want to shorten our M4 by 40mm cap screws here, and we're going to want to shorten the 30mm. You might be wondering, well, why the heck didn't I just buy 30mm cap screws? Well, I'll show you. This is for the idler tensioner, and I'm going to put a spring on here, and this gets installed down here. Now it's got a nice smooth action on the shaft of the bolt, which doesn't have any thread here. If you buy a 30mm cap screw, chances are it's not going to have this smooth shaft. So that's going to make sure we get a nice smooth action on our spring tension. So I'm going to mark these at the 30mm point, measuring like this. I'm not going to include the head of the cap screw, just the shaft, and I'm going to cut them right at the 30mm point there. So now I'm going to install our M3 nut into our Nema drive gear. This can be a little tricky to get lined up and pushed in, but with a little bit of effort, there we go, you see it's lined up there. Now I'm going to just get the first couple turns of the M3 grub screw started. And now I'm going to install this on our Nema motor. I'll make sure the grub screw lines up with the flat part of the shaft on the Nema motor. I'm going to torque up the grub screw. Doesn't have to be very tight because there's not going to be much torque on that gear. Now we can install the the motor onto our main extruder body. There is a method to how this is put together, because the one of the drive gears actually covers some of the Nema motor screws and you can't get to them later, so do follow the procedure or it'll make your life very, very tricky. The Nema motor is mounted with the M3 by 6mm screws, cap screws. Don't do them up all the way, we want the motor loose. As you can see, the motor is mounted on slots for adjustment, and we want to use that adjustment later. So now I'm going to take my 70mm drive gear bolt and start passing it through the large dual helical drive gear here, and I'm just going to pass the bolt, line the gear up with the gear on the stepper motor, and then pass the bolt through the bearings. So now what we want to do is make sure the two gears are lined up, and with the adjustment screws loose on the Nema, we just want to push the motor over to a position where it's engaging the teeth on both gears without any slop, but also isn't trying to push or crush the gears out of alignment. I'm then going to take an Allen key and just tighten this single cap screw on the corner here, and then I'm going to remove the drive gear and the screw, and then I can go ahead and tighten the other two cap screws, and that locks our motor in its final position. So now I'm going to install our drive gear. I'm going to take my M5 by 70 drive bolt, pass it through our gear, and in my case I'm going to require 7 washers, though you might require more or less depending on how your Nema motor is mounted and its gear, but I'll show you how to figure that out in a moment. So I'm just going to back off the bolt that's just above the washers, and I'm going to slide the gear and line it up with the gear on the Nema motor. I'm just going to stop after the first bearing and drop in our filament drive gear, and then I can proceed to push the bolt all the way through. And then I'm going to align the hex on the bolt with the drive gear and push that through. And then I can install a washer, and this is where our small gears come in with the keyway. The first one doesn't matter how it's orientated, the second one does, you'll see that later on in the video. I'm going to install another washer, and then finally a Nyloc nut. I'm going to hold the gear with this hand and do up the nut. Now it's important that we don't over tighten. We don't want any movement, any sideways movement in our drive gear, but we don't want it over tight and putting pressure on the bearings either. Now this is where the 7 washers come in. Depending on how this gear is mounted, how far in or out of the extruder body, you're going to need more or less washers, so just experiment, and of course you can also adjust this gear a little bit as well. So 7 is the magic number for my case, your mileage may vary. So now it's time to install our idler tension springs. I've already installed one right here, I'm going to install the other. This is where our M4 cap screws we cut down to 30mm come into play. I'm going to put a spring over the cap screw, I'm going to pass it through the bolt hole, I'm going to install a nut. This is an M4 Nyloc. Put the Allen key on one side. This is where it helps to be an octopus. Hold that with my Allen wrench, and basically you just want the bolt to just barely pass through the nut. That's all we really need, just for it to hold. And that's our idler tensioners. Now you can replace the springs with lighter or heavier duty, really doesn't matter, that's some experimenting. I found it didn't seem to matter too much what sort of springs I had in there. So now it's time to assemble our idler, and I'm going to take our M5 by 60 drive bolt and I drop in one of the filament drive gears, paying attention to orientation as well. And I'm going to install 4 1mm washers. Now this second gear we're going to install, this does matter what way it's orientated. You can see when you look at the gear it's almost got arrows. Now we need to point those arrows to get the teeth to mesh properly towards each other. Having them like this will not work. So I've got to install my gear orientated this way. Put on a second washer after that, and then of course finish it off with a Nyloc nut. Same deal as before, we want it snug without being over tight. So before we install the idler on the extruder body, we have to fix our filament drive gear. And you can see it's got a bit of adjustment here, so that if it's misaligned, we can slide it over and fix it down wherever we need. Now the easiest way to do this is to get it on the right angle, and it's a bit hard on the camera, but in real life it's much easier. Is to get on the right angle and look down the filament hole here and slide the gear with your thumb until it lines up with that hole. And once that's done, simply tighten the grub screw and that filament drive gear is locked in place. So now we can install our idler onto the extruder body. And to do that, I'm going to slide the extruder into its spot, and with my thumb I'm going to compress the tensioner springs, and I'm going to turn the drive gear till this hole is cleared, and then I can install our countersunk M4 that we cut down to 34mm earlier. And this countersunk is screwing into a nut we installed on the back earlier right here. So now we've got our idler assembled. So now we've got one job left really on the assembly of the extruder, and that's to align this other filament gear. And again, on camera, not typically easy, however not very hard in real life to rotate the filament gear until you can see the grub screw. I've got my Allen wrench in the grub screw, and I'm just going to use the Allen wrench to slide the filament gear on the drive gear, and then once it looks lined up with the previous filament drive gear we installed earlier, I'm just going to tighten up that grub screw. And that is our extruder assembled. Now this part of the instructional build doesn't really apply to the extruder. This is just a mount I've printed for my printer. I don't expect this to work on everybody's printer. I mean, great news if it does. For reference, the X-Carriage 8mm guide rods have 45mm spacing centre to centre. So this will work if you have 45mm spacing centre to centre on your X-axis guide rods. If not, that's a bit of a shame. The only thing I can suggest is this, all this extruder requires to mount is a flat surface, and it uses M4 cap screws for mounting hardware. Got 2 holes here and 1 here. This is my limit switch on this side, and this is a mount for the auto bed leveling system, which you'll see later how that goes together. So I will include these parts on the Thingiverse page for the extruder. However, I don't expect that it's going to work for everybody, as I mentioned. So installing the Hotend, once you've got the extruder body mounted on your 3D printer, it's as simple as sliding on your Hotend, and it should be a snug fit. We do not want this thing moving about. Putting on the locking block, making sure it's not upside down, and then securing it with these M4 cap screws. So to install a PTFE liner from the extruder gear all the way down into the E3D Hotend, just remove the idler arm with the one singles bolt, and we're going to insert the PTFE liner. You have to bend it a little bit to get it started, of course, and then push it all the way down into the hot end, and then I'm just going to trim it flush with a craft knife. It's a little bit tricky with the camera in the way, but I'll try to do it. There we go. Now you can see that PTFE liner is just below, out of the way of the extruder gear. So remember back to the start of the video when we glued in a M4 nut right on the top of the extruder body here, and that's for the PTFE liner to screw into. So how do we thread our PTFE liner? Well, the first thing we need to do is take a 2mm drill bit, and I'm going to hold it in a pair of pliers, because if you do this in a drill and the drill busts through the side of the PTFE liner, it's probably going into your hand, so this is a safer way of doing it. And I'm not going to push hard this way for the same reason. I don't want to end up with a drill bit stuck in my fingers. And I'm just going to basically twist the PTFE liner, applying a little bit of pressure until we've cut around 10 to 15 millimeters of the PTFE liner. Now why did we need to do that? Well, what happens is when we end up threading the tip of this PTFE liner to screw into the extruder, it ends up crushing it a little bit, and the filament can no longer pass through easily. Now here's an M4 nut, and you might be lucky and try to get this started, but it's very difficult. So there's another trick we need to do. I'm going to use a utility knife or craft knife, and I'm just going to chamfer the end of the PTFE liner. So now with that chamfered, I'm going to try and thread on this M4 nut. Now you do have to give it a bit of a push to start to get those threads to cut, but once you get it started, it's really quite easy to thread. So I'm going to thread about 10 mil or about 5 mil after the nut. I'm going to back the nut off. And you can actually visibly see that the liner is smaller where we've threaded it, which is why I mentioned we need to drill it out first to a larger size, so that'll still pass the 1.75mm filament through. So now this can get threaded into the top of our extruder body. So if you were constructing your own dual drive extruder, hopefully you've got a working product at this point in the video, and now I'm going to go into a couple of the settings, changes and tweaks I had to do to get the most out of my dual drive extruder. The first thing I went ahead and did was change the output current of my stepper driver to match that of my motor, in my case 1 amp. While I was at it, I also reduced the micro stepping from 1/16 to 1/4 stepping, and this results in a better overall holding torque. After I made these adjustments, I had no problem with this little pancake stepper motor not skipping steps. It's absolutely perfect for this application. The next thing I had to do was obviously adjust my steps per millimeter value for the extruder. And if you want to learn how to do this, I'm going to make another tutorial video explaining how to correctly calibrate your extruder for the steps per millimeter value, and I'll leave a link in the video's corner for that. After you've calibrated your extruder, hopefully you're getting some awesome prints, and I'd love to have some feedback on this extruder as well. If we see any problems consistent with a few users, then maybe we can look at doing a revision of this dual drive extruder as well. Other than that, thank you very much for watching. I hope you enjoyed this video, and if you did, please hit that like button, it would be much appreciated. And if you enjoyed this video, I'm sure you'll enjoy many future videos. Hitting that subscribe button, I'm sure, will be worth your while as well. Thanks for watching. I'll see you in the next one. Bye for now.